6 फिर से एक बार डिस्कस कर दीजिए.
See, in question number 6, what do we have to do? We need to start working with a cubic Hermite polynomial. So a polynomial, first of all, you have to find the Hermite polynomial for values fa, fb, f prime a and f prime b. Okay, and when you with that polynomial you have to integrate your function. Have you proceeded in the same manner? Tell me, have you proceeded in the same manner? If you have proceeded in this manner and you're facing the issue, then we have to discuss it for sure. Okay. So if I'm not getting any answer, what should I do? Am I audible?
Yes, sir.
Okay. So have you proceeded in the same manner, that finding the interpolation at fa, fb, and f prime a and f prime b, and then solving?
नो सर, समझ नहीं आ रहा था क्या करें.
Okay, please try it in this manner. If you still face a difficulty, we will surely discuss it.
Okay, sir.
What about question number 7? Are you guys trying to solve the problems on your own before coming to the tutorial sessions?
Yes, sir.
So tell me, what's question number 7 doable? Yes or no?
No, sir. Error part नहीं हुआ.
Which part?
Second part, I minus IH is equal to 3 by 8 H power 4. How to show this?
Okay. उससे पहले क्या करना था इस प्रॉब्लम में? उससे पहले बस हमें क्वाड्रेटिक पोलिनोमियल देना था, राइट? ओके. we have to interpolate a function f at point 0, h and 2h, right? So let P2 be the quadratic interpolation of f such that P2 of 0 is equal to f of 0, P2 of 1 is h is equal to f of h, and P2 of 2h is equal to f of 2h, right? So we can write P2x in two forms. First one, the Lagrange interpolation, which is L naught of x into f at 0 plus L1 of x f at h plus L2 of x f at 2h, right? So this is one way. But also P2 of x will be nothing but P2 evaluated at 0 plus x times P2 prime evaluated at 0 plus x square upon 2 factorial P2 double prime equal to 0. P2 double prime evaluated at 0. Does this make sense? Because P2 is a polynomial of degree 2, so it will be the expansion, right?
Yes, sir.
So what I will do is I will transform my P2 prime 0, P2 double prime 0 in terms of F1 and F2, FH, F of 2H in all those. Okay, so what I'm saying is, you know that P2 of x was x minus h, x minus 2h upon 2h square f at 0 plus x into x minus 2h upon minus h square f at h plus x into x minus h 2h square f of 2h. That is from here. So what I am doing is I just want to rewrite this polynomial in this form. Okay, that is my goal, initial goal. Okay, so you just can find P2 prime x. It will be x minus h, x minus h plus x minus 2h upon 2h square f at 0 plus x minus 2h upon minus h square f at h plus x minus h on 2h square f of 2h. So basically P2 prime at 0, if you calculate, it will be 1 upon minus 3 upon 2h f at 0 minus minus plus 2 upon h f at h plus minus 1 upon 2h f of 2h. You can also write it as this, h minus 2h upon 2h, right? I will tell you why we are doing this. Till here, is it fine?
Yes, sir.
So similarly, you can solve P2 double prime evaluated at 0. It will be 1 upon h square f of 0 plus minus 2 upon h square f of h plus 1 upon h square f of 2h. Rewriting of 0 minus 2 times f of h plus f of 2h upon h square, right? So basically, P2 polynomial will be this. F at 0 plus minus 3 times f of 0 plus 4 times f of h plus f of 2h upon 2h times x 0 f of 2h s square x square, right? You know that integrating this function is fairly easy now, because you just need to do, if you integrate p2 of x from 0 to 3h, now it will be 3h times f of 0 plus 3h whole square upon 4h times minus 3f of 0 plus 4 times f of h minus f of 2h plus 3h whole cube upon with 3h square f of 0 minus 2 times f of h plus f of 2h, right? Are we clear
Yes.
till here? Okay, so if I write extension of fx, it will be f of 0 plus x times f prime 0 plus x square upon 2 factorial f double prime 0 plus x square upon 3 factorial f 3 0 plus power 4 upon 4 factorial for at some side. This is my remainder term. Right? Is it fine till here?
Yes, sir.
Okay. Now look at this. Find f of h. It will be f of 0 plus h times f prime 0 h square upon 2 factorial f double prime 0 and f of 2h right? Is it fine? I'm just substituting x instead of h. Now do this. Minus 3 times f of 0 plus 4 times f of h minus f of 2h. Why am I doing this? Because when I integrate this function from 0 to 3h, basically I'm integrating this thing from 0 to 3h, so my terms will be in this form: f0, f prime 0, f double prime 0, and so on, right? So I want to transform this term into f prime 0, f double prime 0. Okay? Is it making sense? Because I can't write f prime 0 in terms of f of 0 and f of h. So what I will try to do is I will write this thing: minus 3 times f of 0 plus 4 times f of h minus f of 2h in terms of these f prime 0, f double prime 0, and so on. Can we do that?
Yes, sir.
Okay, so it will be minus 3 times f of 0 plus 4 times f of 0 plus f of 0. It will be minus. So this term plus 4 times h f prime 0 minus 2h f prime 0, right? This term 4 times f of h minus f of 2h I'm doing, and this term will get cancelled, right? 4 times h square upon 2 factorial minus 4h square upon 2 factorial, right? So plus it will be 4h cube upon 3 factorial minus 8h cube upon 3 factorial f3 at 0 minus 12 is power 4 upon 4 factorial f4 related side. So basically if I write it again, so it is getting cancelled. 2h f prime 0 minus 4h cube upon 3 factorial 3 at 0 minus 12h to power 4 upon 4 factorial f4 validated side. And I want, if I divide it by 2h also, so it will be 2h square, and here it will be 6h cube, right? So make it 2 and make it 2h. Fine. Are we clear till here?
Yes, sir.
Okay. Now do one more thing. We will solve this also. So f of 0 minus 2 times f of h plus f of 2h. So it will be f of 0 minus 2 times f of 0 plus again f of 0. These two terms. Okay, let me use a new color here to repeat it. F of 0 minus 2 times f of h plus f of 2h. It will be f of 0 minus 2 times f of 0 plus f of 0. These two terms plus minus 2 times h f prime 0, this one, and plus 2h f prime 0 plus 2 times of this term again minus 2h square upon 2 factorial plus double prime 0 plus 4h square upon 2 factorial double prime 0, and for the rest I am writing directly 30 plus 14 h power 4 upon 4 factorial f4 at 0, right? So these terms are getting cancelled again. So what we will get is h square f double prime 0 plus 6h cube upon 3 factorial. So okay, f3 0 plus 14 h power 4 upon 4 factorial 4 will get that, right? So if I divide this whole thing by h square, so upon h square will be there. So it will be f double prime 0 plus 6h upon 3 factorial f3 0 plus 14h square upon 4 factorial f4 side, right? It seems to be somehow lengthy, but if you do it step by step, it will make sense. So let me recall what we have done till here. We were giving a polynomial interpolation for these 3 points. So I wrote this polynomial as P2x, okay, and then we wrote P2x in terms of this usual form that 1x x squared. So we got this. Okay, and then we just integrate. So after integrating, we got these terms, and I am re-evaluating these all of these terms in terms of f prime 0. So basically derivatives of x evaluated 0. So I'm transforming these all terms. Okay. So basically what do we got? Integration 0 to 3h p2 of x is equal to 3hf0 3hf0 plus this term 3h square upon 2 into this term, and we have evaluated it here. So it was okay. I think it should be 3h whole square, right? Yeah, 3h whole square, and then we have f prime 0 minus 2h square upon 3 factorial f 3 0 minus 6h cube upon 4 factorial f 4 of psi, and then for the remaining term, this term plus 3h cube over 3, and for the rest of the term we got this f double prime 0 plus 6h upon 3 factorial f 3 of 0 plus 14 h square upon 4 factorial f 4 of psi. Right? And if I just integrate this function, this one, so let it make it hash. So from hash, what do we get? Integration 0 to 3h f of x dx is equal to 3h times f of 0 plus 3h whole square upon 2 f prime 0 plus 3h whole cube upon 3 factorial. Okay, here it will be factorial again. F double prime 0 so did I done something wrong here? Just a second. So if I integrate this function, we will get 3h times f of 0. It will be x square upon 2, 3h whole square upon 2, and then it will be x square upon 3. So 3h whole cube upon 3 factorial, right? F double prime 0 plus 3h whole power 4 upon f 3h 0 plus 3h whole power 5 upon 5 factorial f 4 0. Now you just need to subtract these two terms. So you will get this 3h times f of 0, 3h square term f prime 0, and 3h cube upon 3 factorial term f double prime 0. These all terms will get cancelled out. So you will be left with something constant terms into f3 at 0, which will be nothing but this solving and this term plus this some h power 5 time at 4 side, right? Are we clear? If I subtract this thing, fx dx 0 to 3h minus 0 to 3h p2 of x dx, then I will get some c1 times f3 0 plus some c2 times h power 5 f4 of psi, right? And if you want to see the power of f3, so you can see that it is some h power 4 only. Yeah. Does this make sense to us now? See, you have to tell me is it making sense or not.
Yes, sir, it is clear now.
Okay. So, shall we proceed to the next question? Read question number 8 in time. Is it doable? Okay, in question number 8, let me give you a slight hint. Since the rule is exact for polynomial of degree 1, so basically summation wj dot 1 here running from 0 to n is nothing but entail a to b 1 dx, which is b minus a. So this is given to you. Can question number 8 be done now? I don't think there is anything left in here now. We have given error in fi and use this term. Summation wj is equal to b minus a. Yes or no?
Yes, sir.
If we go to question number 9, so do you think something of this sort has already been done in the class? There you were having just fx instead of xfx, and limits were from -1 to 1, right?
Yes, sir.
So what should we do? Ma'am must have told you that if we have limit from a to b, so our first prime target is to convert the limit from a to b to -1 to 1, right?
Yes, sir.
So question number 9. So integration 0 to 1 x times f of x dx. So we have to transform it to -1 to 1, and let me see the formula directly for here. Yeah. So it is b minus a by 2. So basically 1 minus 0 by upon 2 minus 1 to 1. So whatever is inside, so we do okay, take g of x to be x times f of x. So we want g of b minus a upon 2 times x plus a plus b by 2. So basically it will be b minus a will be nothing but 1 minus 0, and it will be 1 plus 1. So basically we have 1 upon 2 minus 1 to 1 g of x plus 1 upon 2 dx, right? So it is nothing but 1 upon 2 minus 1 to 1. So for this term, now suppose we have this thing with us. So take a new function h of x as g of x plus 1 upon 2. So this integral is nothing but this h of x dx, right?
Yes, sir.
So for this function, we know 1 point Gaussian quadrature and 2 point Gaussian quadrature formula, right?
Yes, sir.
So if I do it for 1 point only, so it will be nothing but 1 upon 2 times h of 0, right?
Yes, sir.
So h of 0 will be nothing but g of 1 by 2, which will be nothing but 1 upon 2 times f of 1 upon 2. So this is the formula for this one. So basically w1 will be 1 by 2 and x1 will be 1 by 2. Clear?
Yes, sir.
So for the time being, can I assume that we are clear with assignment sheet 6?
Yes, sir.
Okay. So then jump to assignment sheet 7. So I think Fowler's method was discussed in yesterday lecture only, right? If I'm not wrong.
Yes, sir.
Yes, sir.
So I will not discuss problems regarding Fowler's method today. You guys read the method carefully and try doing the problems. So we will discuss question number 1, 2, and 3 today of assignment sheet 7. And please read all the 3 questions because all of them are more or less same. And if you want to prove these terms, then you have to use the same derivation which ma'am must have taught in the class, that f prime x is equal to dhf of x and so on. So I'm thinking to discuss at least one in the class. So please read all of the 3 problems and tell me which should be discussed.
Sir, second.
Because it is having third derivative.
सर बाकी दो हो गए हैं, इसलिए
So what about rest? Like rest of the class? Will it be fine if we discuss question number 2 as of now? Okay. Let us start with question number 2. Question 2. Assignment sheet 7. Okay. So what is given? We have to approximate f triple prime of x naught whose error term is of order x squared. So error term, for the error term, do not really bother about because it will come naturally. Okay. So do not bother that I have to anyhow find h square. It will come. So what is it saying? We have to expand f in the Taylor form and evaluate it at 4 different points and try to get f triple prime of x naught. So basically what the question is asking you, so if I write, I think this is the notation ma'am was using here, right?
yes, sir.
So let me write x of minus 2 as x naught minus 2h, x minus 1 as x naught minus h, x1 as x naught plus h, and x2 as x naught plus 2h. So they want us to write in this form, plus p times x minus 1 plus c times f of x1 plus d times f of x2, right? Okay, just wait for a minute, I will get back to you guys. Okay, let us start it again. Yeah. So we want to write d cube h of x naught in this form, right? So this is what question is demanding us. Okay, and it is also giving you one hint that we have to expand f on 4 different points. So let us write the Taylor expansion of f. It will be nothing but around x naught, right? F of x naught plus x minus x naught f prime of x naught plus x minus x naught whole square upon 2 factorial f double prime x naught plus x minus x naught whole square upon 3 factorial of 3x naught for f x naught plus x minus x naught upon 5 upon 5 factorial f by calculated inside. Okay, so this is the Taylor series. So if I write f of minus 2, it will be f of x naught minus 2h times f prime x naught plus 2h whole square upon 2 factorial f double prime x naught minus 2h whole cube upon 3 factorial f 3x naught plus 2h upon 4 factorial f 4x naught 5 factorial f 5 of psi, right? So we are, because x minus 2 minus x naught is nothing but minus 2h, right?
Yes, sir.
So similarly we can find fx minus 1, it will be fx naught minus hf prime x naught plus h square upon 2 factorial f double prime x naught square upon 3 factorial f 3x naught plus power 4 upon 4 factorial f 4x naught minus h power 5 upon 5 factorial f5 at side, and similarly fx1 and f of x2. Okay, so what do we need to have? A times of this term, that we put it as Let me put this one as star. It has 1, 2, 3, and 4. Okay. So using 1, 2, 3, and 4, and this one. So what do we want? A times this term, B times this term, C times this term, and D times f of x2. If we add all of these, it shouldn't contain any term related to f of x naught, f prime x naught, f double prime x naught at least. Clear? This is what we have done when we were doing dh of fx, right?
Yes, sir.
So basically, if you coefficient of, let me write it as coefficient of f of x naught on right hand side. I am writing first of all on right hand side of a times f of x minus 2 plus b times fx minus 1 plus c times fx1 plus t times f of x2. So coefficient of f of x naught will be a plus b plus c plus d. We want it to be 0, right? Now coefficient of, if I write coefficient of f of f prime x naught, so if you see, it will be minus 2a from here. Okay, let me write h also, h f prime x naught. Okay, minus 2a from here, then minus b plus c plus 2d, right? We want it to be 0 as well, right? And then coefficient of s square upon 2 factorial f double prime x naught, it will be from here 4a plus from here b, then plus c plus 4d equal to 0, right? Are these three equations fine to us?
Yes, sir.
And what will be coefficient of h cube upon 3 factorial f triple prime x naught? If we see, it will be minus 8a minus b plus c plus 8d, and it should be equal to 1. So if it will be h cube upon 3 factorial, right? Equal to 1. Because coefficient of f triple prime x naught, in the left hand side it will be this one, and on the right hand side we want it to be just 1, because we want an approximation of f triple prime at x naught, right? Clear? Is it fine?
Yes, sir.
Okay, so from, say, let me give this equation 5, 6, 7, 8. From equation 5 and 7 we get b plus c is equal to minus a minus d, and from here it is minus 4 times a plus d. So basically a plus d is equal to 4 times of a plus d. So this implies a is equal to minus d at least, right? And using 5, b is equal to minus c, right? Is it fine? See, from here b
Yes.
plus c is equal to minus a minus. Okay, good. So now use these values in equation 6. using value of say a comma b in 6. So what do we get? Minus 2a will be just 2 times d, then minus b will be just c, plus c plus 2 times d is equal to 0. So c is equal to minus 2d, right? Fine.
Yes, sir.
Okay. And now using 8, what do we get? Minus 8a was nothing but 8 times d, minus b is nothing but c, and c is just minus 2d, plus c is again as minus 2d, plus 8d is equal to 6 upon h cube. So basically d is nothing but 1 upon 2h cube, right? So what do we get here? D cube h f at x naught equal minus 1 upon 2h cube times f of x minus 2. Then d is equal to minus c is equal to minus 2d, so it will be 1 upon plus 1 upon h cube fx minus 1 minus 1 upon h cube fx1 plus 1 upon 2h cube fx2. So if I rewrite it, it is nothing but f of x2 minus f of x of minus 2 plus 2 times f of x of minus 1 minus f of x of 1 upon 2h cube, right? Are we clear till here?
Yes.
Okay. So what if I write this thing? So what if I write f triple prime x naught minus t cube h f of x naught? What it will be? It is saying do this f triple prime x naught minus of all these terms. So if I do f of x2 minus f of x minus 2 and so on, so basically here. So what are we up to here? If we solve this f of x2, f of x of minus 2, if we substitute all these values here, we will see that it will be 0, this thing will be 0, this thing will be 0, and it will be f triple prime x naught, and this term will also be 0, because if you see the coefficient of f4 x naught, you will find this thing also. So what you will left with is just this term. So basically x minus x naught is nothing but h power 5. We take it as h power 5 and then we have to divide it by 2h cube and then f4 of psi. So now from here you are getting it to be like this. So it is h power 5, h square upon 2 f5 of psi. Is it making sense or should I repeat it? Okay. Let me frame it more properly for the time being. Okay, just stop this. If you just do this f of x2 minus f of x of minus 2 plus 2 times fx minus 1 minus plus fx. If we solve this, okay, so f of x2 minus f of x of minus 2 will take f of x naught to be 0, right? And this term will take again f of x naught to be 0, so it will not contain any term of fx naught, right? That how we have solved it. So what I can say is it is at least f triple prime at x naught plus, for sure there will be some coefficient of h power 4. Let me write those. It is 16 h power 4 upon 4 factorial. So let us do it here. Sorry, just a second. Yeah. So I don't know, somehow the pencil is not working. Just a second. Just a minute. The pencil is not working properly. Okay, I'm sorry, the pencil is not working at present. So was it fine till here at least? Let me, since the pencil is not working, I have to just dictate it. So are we clear till here?
Yes, sir.
Okay, so if I do this f of x2 minus f of x of minus 2, okay, see this. So f of x of minus 2 will have the coefficient of f power 4x naught. If we take the coefficient of f power 4x naught, then it is nothing but 16 h ki power 4 upon 4 factorial, right? And if you see, f of x2 will also have the same coefficient of f power 4 of x naught, right? You can observe that the coefficient of even derivatives of f of x of minus 2 and f of x2 both are same. Similarly, even coefficient of coefficient of the even derivatives of f of x of minus 1 and f of x of 1 are same, right?
Yes, sir.
So basically, if I do this f of x of 2 minus fx minus 2 plus 2 times fx minus 1, and it is minus, right? So it is just a misprint, it is minus. It is minus 2 times f of x of 1. So it will not have any powers of, sorry, it will have zero coefficient for f power 4 fx naught. So fourth derivative of f, right? For the fourth derivative f4 x naught, coefficient of fx2 minus fx minus 2 plus fx minus 1 minus f of x1 will be 0, right? Okay, somehow it works, started working. So what I'm saying is, if I do this f4 x naught up, so coefficient of this here, it will be what? For f of x2, it will be 2h power 4 upon 4 factorial minus, for f of x minus 2, it will be this 2h power 4 upon 4 factorial plus 2 times for f of x of minus 1, it is minus h power 4 upon 4 factorial plus 2 times h power 4 upon 4 factorial, right? Here. Are we clear? Which is nothing but 0. So basically, what do we have? F triple prime x naught plus f5 of x naught. And for f5, we will surely have this 32h power 5 upon 5 factorial plus again 32h power 5 upon 5 factorial plus 2h power 5 upon 5 factorial plus 2h power 5 upon 5 factorial. Right? Are we clear till here? Sorry, I made a mistake here. It will be plus 2 times minus, so it will be minus, and it will again be minus. So basically, it is nothing but f5 x naught and 60 upon 120 h power 5. So it is nothing but 1 upon 2 h power 5 f of x naught. Right? So here it was q upon 3 factorial. Sure. So, but we'll see is we have to divide it by h cube, 2h cube also, right? Then only we will have this. So d cube h fx naught. So let me put it here. It will be 2h cube times plus this. And it is not x naught, it is psi. My mistake. So if I do this d cube h fx naught, it was this whole term divided by, so let me put it, it was f of x2 minus fx minus 2 plus 2 times f of x of minus 1 minus 2 times fx1 upon 2h cube was also there. So if we divide this thing, it will be f triple prime x naught plus 1 upon 4 h square f5 of psi. So now you can see that in the error terms, we are having h square term. Are we clear here? Is it fine? Okay, let me stop then. So please try to do all these calculations on your own again so that you can have a better understanding. And I think the lecture has already been recorded, so you can always go and recheck where you might have doing something wrong if you are not getting the correct derivation. Okay, then we will stop here. And in the next class, we will discuss about Euler's method and Runge-Kutta method.